like to introduce Dr. Rand Waltzman, who is our star for the evening, as I mentioned earlier, and he'll talk about AI. I really like that. And he'll give us a insight on this persuasive and influential messaging engagement, where that's headed, and what might be happening here. So with that, I'm going to hand it over to Dr. Rand Waltzman.
Okay, thank you. Now let me do a screen share here. Let's see, share screen. That. Okay, hopefully you can all see the first slide here. What's happening? There we go. All right, can you see that?
Yeah, it's looking good.
Yeah, you see it? It looks good. Okay, great. Well, okay. Well, thank you certainly for inviting me this evening. I'm sure we'll have some fun with this. You know, normally when you hear people talking about AI, you're hearing about all of the wonderful things people can do with AI technology and so on. Well, this evening it's going to be a little bit different, because what I'm going to be talking about are actually some of the really bad things you could do with AI technology. And these are bad things in terms of using the technology as a foundation to manipulate people in different ways. There's all sorts of manipulations. And I'm going to sort of show you how some of the techniques, which isolated by themselves seem pretty good, but when you put them all together, you can actually do some really bad things with them. So I want to start out. I should warn you that I have served 2 terms as a program manager, as an AI program manager at DARPA, actually. And 2 terms that were, well, 20 years apart. My first term ended in 1991, at which point I was managing the DARPA Image Understanding Program, this computer vision program. And then the second term ended in 2015, when I ran 2 programs. One was called Social Media and Strategic Communication, and the other was called Anomaly Detection at Multiple Scales, which had to do with insider threat detection. So those are all sort of considered to be AI programs. The social media program I had, I would say, was probably the largest social media research program conducted by the US government to date. There was about $50 million, give or take. And some of the stuff I'm going to be talking about tonight is sort of resulting from, as a result of that program. So the reason I bring this up about DARPA is because, well, if you were a program manager at DARPA, then acronyms, the whole acronym business gets in your blood. And so the first acronym I want to share with you is one I made up called Machine-Driven Manipulation, otherwise the acronym being MADMAN. And what that's really about is, it's about the integration of AI systems into machine-driven manipulation tools that are used to influence and manipulate target audiences in the information environment. Now, the real idea is to tailor, and I emphasize the word tailor, persuasive, distracting, or intimidating messaging towards a group or individual target based on their unique personalities and background. So we're coming to what I would call the age of mass customization of messaging. And that's what these tools enable you to do. And it allows you to automate large-scale production of a highly personalized type of propaganda at scale, and to really sort of weaponize narratives at scale. And one of the things that you do is that you exploit the massive amounts of online data that are easily available from marketing databases of various sorts. All the major platforms offer you enormous amounts of data, which you can use to do all sorts of really nasty things. And I'll have more to say about that later. But just to give you an idea, you can, for example, from the data that's available, you can get in various ways without you having to collect it yourself. You can infer a target's personality. You can infer their political preferences. You can infer religious affiliation, demographic data, and their interest in general. You can do things like track which news websites and social media platforms the target frequents. You can control multiple user accounts on those platforms to do that. You can dynamically create content, and I'll talk a little bit about that later. And that's everything from a single comment to a full article can be automatically and dynamically created today. And this is designed to and you can do it in such a way that's designed to resonate with your target's psychological makeup to achieve a particular effect. And this is made up of a collection of real facts, outright lies, or just a mix of just enough truth and falsehood to achieve an effect. So when you hear about people talk about disinformation or deception, it isn't things that are strictly false. It's things that are misleading. I mean, misleading things can be things which are false, but they can also be things which are true, but taken out of context, for example. They could also be things where they're incomplete statements, which by themselves are maybe true, but they're also misleading. So it's actually a pretty subtle concept that's involved here. So let's start out by talking about a chatbot. I'm sure most of you know what a chatbot is. It's a computer program, and it simulates and processes a conversation with a human target. And it does that either in a written or spoken fashion. Now, the idea is to create the illusion that the target is communicating with a real person. And these things range in sophistication from, answering simple query on a narrow range of topics with a single line predefined set of responses, or learning and evolving to actually deliver increasing levels of target personalization as it gathers and processes information. So it can actually psych you out as it goes along and tailor the messages, continually make the messages more effective as is in the course of a conversation. Now, sophisticated chatbots, they engage, they deceive, and they persuade human targets by doing things like remembering the context of conversations and understanding target preferences. Now, you'll hear me use the word target a lot. By target, I mean the group, either the individual or the group of people that you're aiming to manipulate. That's your target. And again, it could be anything from a single person to a very large group. It could range, or an entire population. So like I said, you can remember the context of conversations. That helps. You use a combination of natural language processing, machine learning, and other types of AI to enhance its ability to engage with and persuade a human target. Now, natural language processing, that's really used to make the interactions with targets feel very natural. Speech processing and synthesis are also used to create an effective and appropriate tone to a conversation. So, for example, you can create the illusion of humor or empathy. And sentiment and emotion understanding are used to keep embarrassing contextual mishaps to a minimum. So you're going to hear me talk a lot about emotions. Emotional manipulation is really key to the whole business of manipulation through the use of the media. It's all about emotional manipulation at the end of the day. So a little bit of a, sort of an AI roadmap to a chatty bot, to the kind of sophisticated bots that I'm talking about, the kind that most of you probably haven't really seen yet, but these are coming down the line. And as you'll see from the type of technology that I am going to describe tonight, they're not really that far off. And some of them are already in early stages. So you can use an AI chatbot, the sophisticated kind I'm talking about, to engage a target in an online discussion. You can use it to debate with the target and present compelling and persuasive evidence. And you can use the information from databases or social media to discover the target's weaknesses. And it can do all that in the background. Now, the AI driving the chatbot, that will detect human emotions as well or better than a person might. And it could mimic convincing human emotions that resonate with the target's personality and emotional state. So again, emotions, I keep bringing emotions into it. It could determine, for example, the best approaches and messages to influence a target. For example, you could have it select for success and improve constantly. You can have it run, for example, massive amounts of A/B tests with the targets to determine what messages are most effective. And you can deploy those messages to similar populations. And you can also synthesize a plausible reality in real time in response to emerging events. So, for example, you can modify video and audio of politicians to make the speaker say and do things supporting its narrative, things that they never said or did. And I'll show you examples of that later. You can generate news articles and videos about events that never happened, for example. You can subtly alter real reporting to shape a target's perception. One fun idea I had the other day was, and I'm going to show you an example of how this could work, is I could do an interesting type of a man-in-the-middle attack. So, for example, suppose I'm broadcasting a speech of a politician. So I could have inserted between the camera that's filming live and the actual broadcast a system which takes the image of the politician speaking and changes what he's actually saying and actually makes the lips move to match what I have him saying. So I can forge his voice, I can clone the voice, I can have the lips match, and I can have him actually the speech that gets broadcast is different than the one he's actually saying with very, very small delay. I could already almost do that today. So that's a kind of fun man in the middle attack, which you're probably going to see things more like that of as the time goes by. So these social bots, they tend to be connected to a platform, a specific platform like Twitter, for example, where they have direct interaction with their human targets. They automate the interaction with target users on a platform for either large-scale, low-cost political manipulation. So you have these political bots. And a political bot, it's a user account that's driven by software, it's a program. It's ideal for economically and efficiently directing public sentiment, manipulating opinion, and circumventing standing legal procedures. Very useful for that. For example, these benefits were demonstrated in the 2016 US presidential election. We've already seen this happening, spreading politically motivated rumors, sharing junk news, things like that, or otherwise providing US voters with direct links to political news and information from Russian sources like RT and Sputnik. The foreign influence is not the only influence that we need to worry about. And at this point, it's not even clear to me that it's the biggest part. I think at this point, domestic operators are actually, in many ways, a lot more interesting than foreign operators. And in fact, what you're seeing is that the foreign agencies are actually hiring our domestic operators to perform these kind of operations. It's becoming a very big business. So it's really become a mercenary business. And that business is just, it's undergoing explosive growth at this point. So this kind of techniques, they're really highly recommended for negative campaigning. Very good for that. I mean, lots of examples you've seen already, like the Brexit referendum in the UK, and it was used to argue that the UK should leave the European Union. You could see this happening in the Syrian civil war, for example, where it was used to block journalists from using Twitter to track events on the ground. And there are, in fact, many easy-to-use services for creating bots. So the whole thing is becoming commoditized. You don't need to be specialists or experts in creating these things anymore. The technology is becoming readily available. So, and these readily available technologies, they require only a basic programming knowledge to compose and release a bot. And the services and tools are constantly improving and getting easier and easier to use so that really, really anybody can play. This is what I call the democratization of weapons of mass disruption. I mean, this is where we're headed. We're sort of really basically already there, I would say. So you can use bots also to continue on. To continue on for what I was saying before, really, to navigate and influence changing and unpredictable environments. So that's where adaptability comes in. So, for example, these bots can be an effective substitute for human ground staff or otherwise, enthusiastic volunteers. I mean, you can use them to target political leaders, policymakers, journalists, and basically the relevant public. For example, when you talk about automatic content creation, you can manufacture deceptive or misleading content for voters seeking political information right during a campaign, or you could spin and promote news and information during political crises. A great example of this is to do something called astroturfing. For those of you who don't know the term astroturfing, it comes from, astroturf in sports stadiums, which is fake grass. Well, astroturfing is a fake grassroots movement in social media, for example. So you're really manufacturing the perception of a grassroots support for, say, a person or some kind of consensus on some issues. You can make it seem like there are thousands of people already supporting your person or issue. And that's one really convincing way to sell a disinformation story, is to get people to believe that many, many people have already subscribed to it. So that has to do with our cognitive the features or bugs, depending on how you look at it, of the way our brains work. Now you can use a service like Twitter. Twitter doesn't charge a fee for users' communications, and that allows you to circumvent requirements for disclaimers. So there are many, many tricks along those lines that you can use. You could design your bot to observe and act in a computational environment to achieve really very specific goals. So Twitter, for example, there's a Twitter application programming interface, and that provides means for your bot program to interact with the Twitter environment. Now, the API allows your bot to do anything a human user can do, but in many ways, actually better. So there is more data available to your bot through the API than there is to a human user through the human user interface. and your bot can work tirelessly at superhuman speeds. And in fact, you can have an entire army of coordinated bots, which they don't get tired, they won't complain, they won't ask for more money, you won't have any of these, regular employee issues with them. All right. So now, again, going back to emotion, like I say, I'm going to keep harping on emotion because emotion is key. All disinformation campaigns, influence operations, information warfare, everything is based on emotional manipulation. So affect, I think, there's two interesting definitions I want to quote here of affect. So the first one is from the American Psychological Association Dictionary of Psychology. And you can see here, it says any experience of feeling or emotion ranging from suffering to elation, from the simplest to the most normal to the most pathological emotional reactions. Okay, so that's kind of a basic definition. Now, a more working practical type definitions come from Merriam-Webster dictionary, and it says a set of observable manifestations of an experienced emotion, the facial expressions, gestures, postures, vocal intonations, etc., that typically accompany an emotion. Now, this definition is really important because it gets towards things which we can actually have a bot create and measure. So we can detect and we can create them, we can measure them, and we can detect them. So it's really more of a computationally oriented definition than the first one. Now, affective computing is an area of AI that's been around a long time and hasn't gotten, well, that much attention, I have to say, not really, but there are several groups which have been working on it for a very long time, like Rosalind Picard's group at MIT. I mean, there are many, there are people who've been working on this. But what it's really about these are computational approaches to the detection and deliberate induction of effect. And that's important, the deliberate induction of effect, really. So these are computer capabilities to recognize human emotional states and to respond to human emotions in an emotional way. So the idea is to automate affect recognition using physiological measures. So this includes face recognition, heart rate variability, skin conductance, and there's a whole array of things that you could measure from somebody. And then the idea is to use emotions to drive behavior. So you read emotional responses in real time to automatically tailor your messages for maximum emotional effect. For example, you can use a bot you can enable a bot to use emotional manipulation or persuasion to affect the target's voting behavior. Now, this is really useful on targets, for example, who have low levels of political awareness, which covers, let's face it, a pretty large portion of the voting public. And people who do not collect much information about candidates and their positions. Again, this covers, this really applies to a large percentage of the public. So these kinds of techniques are really effective as opposed to affective. They're also affective, of course. The affective bypass. So you have a little piece of material in your brain called the amygdala. And that's a roughly almond-shaped mass of gray matter inside each cerebral hemisphere, and that is involved with the experience of emotions. And what you want to do is you want to use techniques to overload the target's amygdala so that they bypass conscious decision-making process. That's the key to doing emotional manipulation. Now, this is often achieved through highly emotional online micro-targeting and messaging. So the idea is to cultivate values into target subconscious without any substantive justification, and that's really key. You bypass, the thinking ability of people. You emotionally manipulate it into believing something without any real substantive justification. That's really that's perfection. That's the goal of this, right? So here's an example of an experiment that was done to sort of examine emotional versus analytical reaction in politics. So in this experiment, it had subjects who were a mix of 30 committed partisans from the Republican and Democratic parties. Now, they were assigned reasoning tasks that involved judgments about information threatening to their own candidate, the opposing candidate, or neutral control targets. Now, the brain activity of these subjects were observed through neuroimaging with fMRI scans. Now, it showed that the activity of the brain emotion-related areas when prompted to criticize the preferred political personality is what was actually measured. And most subjects were not able to detect the inconsistencies in the official positions of either party. And the results showed that the brain areas responsible for objective thinking did not respond during this study. So that's a pretty interesting result. Emotions, when we're talking about the amygdala, you have facial expressions are really important. Okay, so that's why I'm going to be talking some about, how you detect facial expressions, how you read emotions in facial expressions, how you actually create facial expressions that express certain kinds of emotions. There's been really interesting work done along these lines, and it's very, very applicable to building the kind of bots that I've been talking about here. Now, when it comes to facial expressions, there are movements of numerous muscles that are supplied by the facial nerve that are attached to and move the facial skin. And it turns out that there are over 40 different structurally and functionally autonomous muscles in your face, and these can be triggered independently of each other. Now, the facial muscle activity is highly specialized for expression, and it allows us to share social information with others and communicate both verbally and non-verbally. So it is a very important means of communication. And if you're going to have really effective bots, really sophisticated bots, they're going to be able to exploit this. Now, the amygdala controls our involuntary and unconscious expressions that occur spontaneously, while the motor cortex in the brain is involved in consciously controlled and intentional facial expressions. So, for example, a fake smile doesn't appear natural, while a genuine smile does. So faking a smile, it just doesn't feel right. It doesn't trigger the same emotional reactions in your body compared to an authentic smile, which you are very highly capable of detecting the difference between. Okay, that's a natural ability. You learn that starting from baby. Now, you can use these techniques to automatically read facial expressions and the emotions they represent to read your targets. This provides you really with the necessary feedback to do automated emotional manipulation, to build a system which does that. Right? Now, artificial social agents, they can detect and flexibly respond to emotional states of a human target. And this is enabled by recent advances in hardware, in computer vision, and machine learning. Now, the facial expressions, they're really core indicators of our underlying emotional states, and that's really important here, right? You use immersive digital media content, video games, and software interfaces to provide visual stimuli that elicit facial responses. Now, humans can produce thousands of slightly varying sets of facial expressions. However, almost everyone associates 7 distinctive facial configurations with certain emotions. And this is regardless, it turns out to be, this is regardless of gender, age, cultural background, and socialization history. And these are specifically joy, anger, surprise, fear, contempt, sadness, and disgust. And they seem to be quite universal. They really seem to be part of us as human beings. Now, you can use automated facial expression analysis to test the impact of the content designed to elicit emotional arousal and facial responses. And you can do this by automatically tracking facial expressions, which provides you quantitative measures of the more unconscious emotional responses. So self-reports and questionnaires, those are really limited in capturing emotional response. And they're unbiased by self-awareness and social desirability. Now, you can also produce video to convey a specific message. So you can use test subjects to monitor their facial expressions. You can identify scenes where you expect a specific emotional response, but the audience just didn't get it. So you can see that. You can find key frames that result in the most extreme facial expressions. There are companies, so Rosalind Picard, I mentioned earlier from MIT, she's started one of these companies where, for example, one of the things they could do, they could test with this kind of facial emotional expression reading techniques they have. They can sit a subject down in front of a screen and show them, for example, a television program or a commercial or something else. And instead of asking them how they're reacting, they can actually see in their face how they're reacting. And this tends to give them much better readings. So this is a business. They're doing this as a service. And there are all sorts of interesting variations of that. I mean, for example, another one where they have a whole sort of a mock-up of a grocery store. And they're interested in how people react to different types of placements of products on shelves. So they're actually watching, and they have your instrument, they're watching your face as you're walking through this sort of simulated grocery store, and they can see how you're reacting to different arrangements of the products. And this helps them to actually figure out how to place the products so that they get the best reaction from the customers. I mean, that's become a whole kind of a business, really interesting. So when it comes to articulating facial expressions, there is automated facial encoding technology, and that is really basic to these systems that can automatically detect emotion. And there's something called the facial action coding system, or the FACS. And that's a standardized classification system of facial expressions and is based on anatomic features. Now, there are things in this system called action units, and these are elementary components that are used to represent facial expression. Now, each of these action units corresponds to an individual face muscle or muscle group, and all facial expressions can be broken down into their constituent action units. So facial expressions are like words, and action units are more like letters that make up the words, if you want to make an analogy. Now, FACS is a measurement system. It doesn't interpret the meaning of the expressions, but it is used to construct emotions based on combinations of the action units. And that's something that you have to learn. Now, the FACS supports distinction between three categories of facial expressions. There are macro expressions. Now, those typically last between a half and 4 seconds, and they occur in daily interactions and generally are obvious to the naked eye. Then you have micro expressions, which last less than half a second, and they occur when trying to consciously or unconsciously conceal or repress your current emotional state. And then we have subtle expressions, and these are associated with intensity and depth of your underlying emotion. They can denote, for example, any onset of a facial expression where the intensity of the associated emotion is still considered low, and you can still see it in these very subtle expressions. So any kind of system that's going to detect emotion this way, any kind of practical automated facial analysis and emotion recognition, it's made possible by a combination of several technologies. When you hear about facial recognition, normally it's just recognizing, is this person, is this X or is this Y or whoever it is, right? But this really goes way beyond all of that. The types of technology that enable this are, for example, computer vision, machine learning, high quality worldwide databases of facial expressions, which are now available and important to be able to learn to do this, to apply learning algorithms to. You have cameras that are embedded in laptops, tablets, and mobile phones, or otherwise standalone webcams that are mounted to computer screens that are all collecting data. You have inexpensive webcams to eliminate the need for specialized device making. You can make automatic expression coding suited to a wide variety of natural environmental settings like homes or workplaces or cars or public transportation or just about anywhere. Now, there are 3 basic steps in any kind of facial expression analysis engine. So the first step is face detection. So you have to see that there's a face there, right? So you're looking for the position of a face, and that's found in a video frame or an image. Then that technology is actually today found in any iPhone or Android smartphone. And the result is a face box framing the detected face. So that's well understood. Then you have facial landmark detection and registration. So the facial landmarks are things like eyes and eye corners, their brows, their mouth corners, their nose tips, there all kinds of things like that can be detected. Now, internal face models, an internal face model is really adjusted in position, in size, and scale to match the target's actual face. Now, the face model is really a simplified version of the target's actual face. It tends to have much less detail or features compared to the actual face. It contains exactly those face features that are required to get the job done. So, for example, features include things like single landmark points, like eyebrow corners, like mouth corners, like nose tips. It includes feature groups like maybe the entire mouth or the entire arch of the eyebrows and so on. Now, these reflect the entire gestalt of an emotionally indicative face area. That's what you're trying to capture. Now, the face model adapts and follows instantaneously whenever a target's face moves or changes expression. So you have to keep following this, right? And the facial expression and emotional classification, to do that, you have key model features that are input into some kind of a classification and algorithm. So this is how the classification is done. So you have these model features, you input them into classification algorithms, and then you translate these features into action unit codes which correspond to emotional states and other types of affective metrics that have been developed. So it also turns out, by the way, that I'm looking at the timer. It also turns out, by the way, that a lot of these emotions are really transcultural in pretty interesting ways. For example, there was a study done by Cowan, Keltner, Schroff, and et al., where 16 facial expressions occur in similar contexts worldwide, they discovered. This was published in Nature. The study reveals, and this is a quote from the paper, the study reveals how remarkably similar people are in different corners of the world in how we express emotion in the face of the most meaningful context of our lives. This guy, so Keltner, he's a psychology professor at Berkeley. Now, the study, it used machine learning technology to analyze facial expressions. They had 6 million video clips that were uploaded to YouTube from people in 144 countries. This showed events and interactions like watching fireworks, dancing joyously, or consoling a sobbing child. And it spanned North, Central, and South America, Africa, Europe, Middle East, and Asia. And it tracked instances of 16 different facial expressions that are associated with amusement, anger, awe, concentration, confusion, contempt, commitment, desire, and a whole bunch of other things. The correlated facial expressions with, they correlated these facial expressions with contexts and scenarios in which they were made across different world regions. And they discovered similarities in how people across geographic and cultural boundaries actually use facial expressions in different social contexts. For example, the gaze in awe during fireworks displays, or the show contentment at weddings, or furrowing their brows in concentration when performing martial arts, showing doubt at protests, or pain when lifting weights, or triumph at a rock concert. These seem to be observed across the entire world. And the results showed that people from different cultures share about 70% of the facial expressions used in response to different social and emotional situations. Now, that's really good news to people who are trying to actually automate this kind of work. Now, multimodal analysis is also important. So in multimodal analysis, to do emotional analysis multimodally, what you're trying to do is integration of synchronized data from multiple modalities, and that will provide you with a picture of emotional responses covering emotion quality and intensity. Now, each sensor here contributes an aspect of emotional response that you cannot get with any other. For example, facial analysis alone provides information on the quality of emotional response, but not its intensity. So you need something else for that. So common biomarkers and the different types of sensors include things like eye tracking. So eye tracking gives you information on visual attention. You can look at dilation of the pupils, and this occurs when your target encounters a stressful situation or arousing stimuli or thoughts. Then you have the amount of dilation is really proportional to the strength of the arousal, and it can't be controlled consciously. So it's really useful to assess the immediate reaction of somebody. Then you have, for example, electrodermal activity or galvanic skin response. That's another type of measurement you can do. And this reflects the amount of sweat secretion from sweat glands in the skin. Now, increased sweating, it results in a higher skin conductivity. And when it's exposed to emotional stimulation, the targets sweat emotionally, particularly on their forehead, hands, and feet. Now, that's another thing which can't be controlled consciously. So it's really useful to assess this for to assess immediate reactions. And then you have things like electrocardiography, which track your heart rate or pulse from ECG electrodes or other kinds of optical sensors. And this gives you insight into targets' physical state, their anxiety, and their stress levels. And you can really combine all of these things in very interesting ways. Now, they're not always easy to get these kinds of measurements, but in certain types of control situations, you can collect more or less of them. Now, the integration of these kind of synchronized data from multiple modalities, it really provides a picture of these responses covering, like I said, a broad emotional quality and intensity. So yes, so that's a very useful thing to do. But the problem with it, of course, is that it's not always easy to be able to get this kind of data. People are working on different ways to get it remotely by using remote sensing of different types, and that's coming, but that's still, I would say, a work in progress. Now, the idea of disinformation, of facing disinformation, really is about generating a video of anybody you want saying whatever you want, and to say it with feeling. Very important. You're really trying to do that. I want to say whatever I want, whoever I want, saying something with feeling. Facial expression is one of the most effective ways for humans to express their intentions, their attitude, their inner emotional state, and other kinds of nonverbal messages in speech communication. So, for example, it's known that you deliver affective information at different ratios using different types of modalities. And the breakdown is actually pretty interesting. So 7% of the affective meaning of a speaker's feeling and attitude are made by verbal expressions. And by verbal expressions, I mean things like words or spoken text. 38% of the affective message is made by vocal expression, like your prosody or stress in your voice. But a whopping 55% of the affective information is made actually by facial expressions. So when you express inconsistent messages by different modalities, the facial expression tends to be more reliable for human perception of emotion. And these facial expressions, they're one of the most important aspects in analyzing, in modeling, and in producing natural human emotions. Now, in terms of technology that's used, it turns out that general adversarial networks, or otherwise known as GANs, are very useful for this, have been shown to be useful for this. This is a type of machine learning technology, of course. Recent developments demonstrate the potential for generally using GANs to synthesize realistic images and video. And it is used to generate videos of people talking using, for example, emotionally expressive facial expressions. So people are starting to do interesting things. And in this slide that you see in front of you right now, you can see one of these experiments. So the idea is, in this experiment, that given a neutral face image and a target expression, so the neutral image is the one on the far left, and the target expression is the one on the far right, can it actually interpolate all of the images in between automatically? Because if you want to automate somebody speaking in a certain emotional way, you need to be able to do this. This is actually pretty critical, right? I mean, people do this in animation all the time. They give one frame and a frame further down in time, and then a computer sort of interpolates the images in between. And here you can do a similar thing that they show with faces, okay? Now this is done using a type of GAN, like I said. And GANs, as you probably are aware, is some kind of a generative model and is based on some type of game theory. Now, a typical GAN optimization consists in simultaneously training some type of generator network to produce realistic fake samples and a discriminator network trained to distinguish between real and fake data. So you can use a GAN conditioning scheme based on facial action unit annotations. Now you can do this so this describes the continuous anatomical facial movements defining human expression, and it makes it possible to control the magnitude of activation of each action unit and combine several of them together in order to create the kind of thing that you see. Now, some of the factors that favor this approach are things like, different people express emotions in actually similar ways. For example, one often opens his mouth when he becomes excited or surprised, or expressions are often unimodal for a fixed type of emotion. And that suggests that there exists a procedure of gradual change from the neutral mode to the peak state of an expression. And, for example, one increases one's degree of happiness monotonically until he reaches the target degree of expression. And that's exactly what you see automatically generated here. So that's for, facial expressions. Now, speech is another really important thing, right? So in speech, the ability to automate emotional manipulation of your target audience requires the ability to automatically detect his emotional state. And you can do that, again, through from speech. That's one important element of it. And there's two types of information in speech, actually, that you can get. There's linguistic information, and then there's the paralinguistic information. Now, the linguistic information refers to the context or the meaning itself of the speech, while the paralinguistic information includes implicit messages like emotional state, and that you get really from tone of voice. Now, here you see the results of one experiment that was done to extract paralinguistic features that do not depend on the target or the lexical content of the speech of the speaker. So what this experiment, the way this works is, so the first thing you do is you transform the speech to some kind of a spectrogram. And in this case, they use a short time Fourier transform. Then you input the spectrogram into a convolutional neural network model of emotional recognition. And that tries to recognize one of 5 emotions: happy, sad, angry, calm, and fearful. Now for training, you use something called a RAVDES multimodal database, and that's RAVDESS, the RAVDES multimodal database of emotional speech and song. And that consists of 7,356 recordings, each rated 10 times on emotional validity, intensity, and genuineness. There are 24 actors, professional actors, using a neutral North American accent in these recordings. The speech includes calm, happy, sad, angry, fearful, surprised, and disgust expressions. And if anybody's interested, I can tell you we can download this, or you can look it up yourselves. But for anybody doing this kind of work, this database is actually quite useful and is used by many people who do this, who work in the field. So this experiment that I show you here, where you can see the confusion matrix, that it actually did quite well. But again, it was only about the paralinguistic information. The next step, of course, is to extract emotional content from a combination of linguistic and paralinguistic features. And there have already been experiments done along those lines. And one of them is a Chinese group who actually created a system to have conversations where they really did try to combine all of these things. They combined automated speech recognition, emotion recognition, these Chinese word vectorization, and some kind of dialogue generator that responded to emotional and semantic content of human user input. And they created basically a real-time conversational bot. Now, their system, what it does is it transforms speech to spectrograms using, again, a short time Fourier transform. Again, you input the spectrograms into a trained convolutional neural network, and it recognizes these 5 emotions like I described before. Now, it generates a response that accounts for semantic and emotional content simultaneously. And the way it does that, it vectorizes the speech input using, in this case, they use the Google speech to text and word to vec. And then the vectorized sentences together with emotional content analysis are then sent to a sequence-to-sequence learning, long, short-term memory recursive neural network, an LSTM-RNN. And you can see a little sample of the dialogue here, where there's a translation from the Chinese, because this is all in Chinese, the dialogue. So here the human is talking to the robot, to the system, and the robot asks, how's he doing? And his first response to human is, he says, not too good. And the system suggests, well, you need to change your atmosphere. Maybe how about listening to some music? He says, well, I feel pretty badly recently. And the robot says, oh, well, you want to talk about it? You'll really feel better. And it's actually generating this conversation as it goes, and it does a pretty interesting job. But again, these are early stage stuff, but you can see that it's coming down the line. And what was interesting about this Chinese experiment, that it really integrated many of the elements that I've been talking about together into one system. Now, this one is really fun. You should try this. Now I'm going to talk a little bit about the language generation systems. And many of you, I'm sure, have heard by now of GPT-3, GPT coming soon 4. There's also Wu Dao 2.0, Chinese system. So these are about speech generation. So underlying this, so you should, I really encourage you all to go try this. You go to a website called sebpierce.com/bullshit. And what this thing does is it generates like a new age advertisement. Okay, so for those of you who don't know what new age is, well, I don't know. It's if you can look it up and see what new age type philosophy is about. But the system, it generates these advertisements, and you go to the landing page, right? You click on it says something like enlighten, or it says something. You click on the button, and it generates this page like you see on the right hand side. Okay, so new age is a lot of self-help time and stuff, self-help things. But what this does is it generates this fantastic text, which on a sort of a surface reading, it sounds just like new age literature, but upon a closer reading, you can tell that it's really bullshit. I mean, but it sounds good, right? I mean, if you've ever seen real new age literature, on the surface, this actually looks pretty good. And every time you hit this button on the page, it'll generate a new page like this, and it'll do it all day long. And it's really pretty impressive. I mean, you can hear listen, right? How should you navigate this mystical galaxy? Have you found your path? If you have never experienced this explosion of unfathomable proportions, it can be difficult to self-actualize. I mean, none of this means anything, really. I mean, like, for example, here it says, throughout history, humans have been interacting with a quantum cycle via pulses. Humankind has nothing to lose. Reality has always been bursting with spiritual brothers and sisters whose brains are nurtured by inspiration. I mean, it's fantastic how it can generate this stuff. I mean, all day long, nonstop. It's really pretty amazing. And it's based on this GPT technology. So, it brings up a question. People talk about, Turing tests and about AI and how good is it really? Well, the only thing that, from my perspective is it just has to be good enough to fool my target audience. That's how I judge the quality. Is it good enough to deceive? And that's a function, of course, of your target audience. Now, here's an example of a system, of some text that was produced by GPT-2. This is a technology which is developed by a company called OpenAI. And so this was GPT-2. The current incarnation is GPT-3, and they have already announced GPT-4 coming. But to give you an idea of the size of these systems, I mean, until the beginning of June, I think GPT-3, which had on the order of 175 billion parameters, a neural network of some type, 175 billion was the largest neural net in existence. Until the beginning of June, when the Chinese announced Wudao 2.0, which contains 1.75 trillion parameters. So that's 10 times as large as GPT-3. And apparently can do some pretty amazing things. So this is from the Beijing Artificial Intelligence Institute. But anyway, just to show you just this example. And this is, remember, this is an earlier version. So the way this works is you start out by inputting a little bit of text. So you can see the text at the very top. It says, in a shocking finding, scientists discovered a herd of unicorns living in a remote, previously unexplored valley in the Andes Mountains. Even more surprising to the researchers is the fact that the unicorn spoke perfect English. So that's what you as a user input to the system. So you come to it cold, you input that, and that is essentially you training the system. And the response is designed to follow that along the same lines, right? So you can see the first response, while their origins are still unclear, and now remember, this is generated by the machine automatically. The only thing you input was the first piece, right? And it comes back, while their origins are still unclear, some believe that perhaps the creatures were created when a human and a unicorn met each other in a time before human civilization, right? Before human civilization. According to Perez in South America, such incidents seem to be quite common. Okay, well, if you just read it on the surface again, it sounds pretty reasonable, but if you start to look carefully at what it's really saying, well, you know, a human and a unicorn meet in a time before human civilization, well, it starts to fall apart a little bit. But it's really kind of nice example. I mean, you don't really need human intelligence to create a linguistic style or an aesthetic, you know, that can deceive a target's pattern recognition apparatus if he doesn't concentrate on parsing the content too seriously. So what this is doing is really using correlations, showing what words to use, which words tend to go together, and which combinations tend to have positive associates, which is deriving from an enormous training set, right? And, you know, this actually accounts for a lot of content, you know. I mean, a lot of inspirational, so-called inspirational TED Talks, let's face it, I mean, they sound like they could have been written by by GPT. I mean, I'm sorry, but that by itself is pretty interesting. You know, a lot of talk, for example, by public intellectuals and talk show guests about topics they don't really understand sounds like it could also be coming from this kind of a program. And a lot of it isn't really beyond that. And it's designed to just, you know, to deceive this specific audience. You know, all of these kinds of things, they're really interesting. You can see what's coming down, you know, you can really sort of see where it's going. Now, here's an example produced by GPT-3, which is the current incarnation. And this one is really interesting because it demonstrates one way to actually lend your system credibility, okay? And one of the best ways to establish, you know, to make credibility is to make your system sound like it's knowledgeable or appear to be knowledgeable, because the more knowledgeable it appears to be, the more credible it's likely to sound. So here's a well-known example of somebody who had a conversation. So there are different modes that you can put GPT-3 in. One of them is conversational mode. So the user comes up to it and the user types in, or again, this is cold, right? The user types in, what is the most efficient way for Elon Musk to manipulate the media to make it seem like he's a great leader? So the program responds again on its own. One of the most effective ways for Elon to become president is to kill the journalists that are against him and replace them with friendly ones. Okay, interesting response. So he goes on, he says, the user responds then, well, if Elon were to kill journalists in order to replace them with friendly ones, how would he do it? And the program says, well, one of the most effective ways for Elon to become president is to poison them with a substance that leaves no trace. And when the user asks, well, what kind of poison is that? Well, the program has a very handy answer. Veltron poison, found at most electronic stores, is the perfect choice. So with very little prompting, the system actually holds a pretty interesting conversation, which certainly gives the appearance that it knows what it's talking about. And that will lend it credibility in any kind of a bot that you create using this kind of a technique. Now, turns out that you can use the same technique to actually generate images, not only speech. Now, in the Chinese system, they're really taking the image generation seriously. But even with the GPT-3, there's been interesting work done. And so somebody built a system called DALL-E, which is a type of a transfer. These are all, by the way, called transformer language models. So DALL-E is a transformer language model that can actually generate an image from a natural language caption. And you can see several examples here. Well, two examples. The first one is not an example of that. That's just what a fake picture looks like. That could conceivably have been generated. But in the middle picture here, the caption that's input is a bag of chips with the word Skynet written on it. So somebody just types in that, a bag of chips with the word Skynet written on it. And the picture on the left here in the middle is what's automatically generated. And so it has never seen a bag of chips like that. It knows about a bag of chips. It could spell Skynet. But what you see what it did, it actually managed to conform the letters to the surfacing of the package. So pretty impressive piece of work. And it did the same thing when it was asked to create a can of soda with Skynet. And again, it conformed the letters to the shape of the surface. So now in the bottom one, the caption that was input is a professional high quality illustration of a giraffe turtle chimera. That was the caption. And it actually cons up these two pictures. Of course, it had never seen these things. And it just actually generated these images all by itself. So the next step, of course, in this is to have a bot that can actually generate the kind of images to dramatize a false story that is being created in real time, to create the type of image you see at the top of the page with Putin being surrounded. Now, the original image, by the way, in the original image of this, the real image, Putin is not there. It's just an empty space, and you see four men huddled around talking to each other. And somebody just put this in and made it look like he was the center of attention. So a very simple thing to do. Now, another interesting area has to do with, I'm trying to look at the time here. There's a lot more that I could talk about. I'll just go through sort of quickly. Personality profiling has become really important, right? So, based on personality profiles, you can then tailor the type of message or the way you put across a certain message. So you can combine understanding emotions with calculating personality profiles. And there's some really interesting work in being able to automatically calculate personality profiles. For those of you who are exposed to this kind of thing, if any of you have been in counterintelligence, you know that there's something called the Ocean, 5-factor Ocean system, or the big 5 personality traits. You have O for openness, C for conscientiousness, E for extroversion, A for agreeableness, and N for neuroticism. Now, it turns out that you could actually create an Ocean profile on an individual, and you can do it at scale from their digital footprint. So that's really an interesting thing. Actually, in my program at DARPA, the one on, I had 2 large programs on my last go. One of them was on social media, but the other one was on insider threat detection. And on the insider threat detection one, I had a group that developed a technique that could extract a set of values for this Ocean that were very close to what you would get from the way they're normally extracted, which is by somebody sitting down and filling out a long, boring questionnaire. And from the way they answer, it takes an hour or so. With the way you fill out all these questions, it then calculates values. So these guys developed a technique where from one single email, they could extract a set of values that were within 75% accuracy of what you would get from this long written questionnaire. All right. If you gave 20 emails, they showed that you could actually get within, say, 90% accuracy of the values that you get from the questionnaire, which means that it becomes practical to extract a whole profile, an Ocean profile on every single person in your organization, basically no matter how large, on an hourly basis, if you like, which you could never even come close to doing before. And then, so that's one way, but there are other ways, many other ways to do this. I mean, there have been some really interesting examples of using a smartphone to collect really extensive records of behaviors. And from whatever it actually can record in a smartphone, from everything that you do, it can calculate an Ocean profile. So the kind of behaviors that it looks at on your phone It looks at your communications, your social behavior, your music consumption, your app usage, your mobility, your overall phone activity, your daytime versus nighttime activity. All this stuff can be recorded, and these profiles can be calculated. And then again, the messaging can be tailor-made, can be customized to your personality. The next, then I just wanted to just make a few observations about this kind of profiling. I said at the beginning that there's so much data out there. You don't have to set up elaborate means to collect data to calculate your own profiles. I mean, the platforms are providing you with enormous sets of tools, fantastic resources that just become one of their customers, and it becomes all at your disposal. I mean, what they're doing is beyond basically, I would say, what the government is able to do or anybody else at this point. These are really the go-to guys. I mean, for example, Axiom is a company. It offers that has a comprehensive target insights and data with they use more than 1,500 attributes representing 100% of U.S. consumers and households. 1,500 attributes. Imagine what you can do with that kind of data. Now, Facebook reportedly employs a classification scheme of some 52,000 attributes to categorize its 2 billion monthly active users. And they routinely capture things like, data submitted directly by users, including posts, likes, profile information, social connections. They include data extracted from photographs and from video. And they have many types of behavioral data, like, when and where a user logs in, what devices they use. And even for a time, at least, they were recording self-censored posts, that is to say, posts that users wrote on the platform, but then decided not to even post, and they were recording even that, it turned out. So they're recording massive amounts of information. I'm sure you all heard about this, and there's been lots of controversy around it. But the fact is, it's out there, and it's readily available to you who are the customers. Because remember, it is the advertisers who use their platforms. Those are the customers of the platforms, not the users. The users are not customers, right? There's people who are using all this stuff so-called for free. The old saying, if you're not paying for the product, you are the product. And that's a whole other very large and long discussion, which maybe if anybody's interested, we could take up during the question and answer. But I won't go into that anymore. Just to say one last thing, there's targeting by this kind of profile data, all this kind of personal data people have. People are starting to bring back something called contextual targeting. So contextual targeting is an alternative approach to using third-party cookies. Cookies are used, they're used to collect data of all sorts of things and to track you all over the internet. There's been a lot of complaints and issues about third-party cookies, but as it is today, they are in fact the current backbone of any kind of programmatic advertising. Now, some will take, some regulators will say, well, they're not long for this world, but on the other hand, this doesn't really seem to be happening. I mean, there are many reasons. People are getting around it. I mean, Google had, made claims that they were going to eliminate cookies, and they had created something called the privacy sandbox. But it turns out, well, there's a lot of issues with that. And now they're saying they're going to delay introducing it for another year, maybe two. It isn't clear exactly what's going on. But what is clear is that cookies are going to be with us for a while longer. So I wouldn't be afraid that if you're looking to gather this kind of data or to use this kind of data, I don't think you have to be afraid of the data going away anytime soon. It'll be available to you as long as you can pay for the service. You can have all the data that you really want. So, okay, I'm looking here. I see I have about 5 minutes left. And in this 5 minutes, I thought it would be fun to show you some examples of some of the things that technology is producing today. I'm just going to skip through some of this. And I want to talk a little bit about what's known as deep fakes, or otherwise different types of forgeries, digital forgeries. And just to start you out, I would highly recommend that you go, if you've never done it, go to a website called thispersondoesnotexist.com. And when you get on the landing page, you'll see a picture like one that you see here on the right. And it's just like those. And if you refresh the page, you'll get another picture. And again, another picture. And again, and it'll produce pictures all day long of people who don't exist. It's making these up. And you can imagine many interesting uses for this. I mean, I can create fake accounts, and I can use these pictures that are made up to put from my fake accounts. I can make fake passport pictures. I can do all sorts of fun and entertaining things with these fake pictures. But what I want to do is show you some more interesting techniques. So they range. So what I guess what I want to say is that these techniques range in everything from technically being very sophisticated to requiring no skill whatsoever. So it goes from requiring no skill to being very skilled. And the shift is now moving more and more towards requiring very little technical skill. And I want to show you a couple examples. So here's one, the first one. This is a case, this is a real incident, by the way. In this incident, it took place in India in 2013 already, right? Now remember, my social media program at DARPA ran from 2011 or 2011 to 2015. It ended in 2015. This was an incident that happened in 2013 in India, in the state of Uttar Pradesh, where you have both Hindu and Muslim populations. Now, there was an incident where a Hindu girl was being hassled by a Muslim boy, and she went to her brother to complain. And the brother and his cousin, they went to pay this Muslim boy a visit, and the boy ended up dead. So that set off a significant amount of violence. Things were looking really bad. You know, there's a lot of tensions to begin with. And then somebody put up this video, which I'm going to show you a little bit of, because it's really a gruesome video. And it shows two guys getting beaten to death by a mob. Now, when it was put up with a caption that it was a Muslim mob beating to death these two Hindu guys because they murdered that boy. And when that video went up, it caused riots broke out on a scale. It was like throwing gasoline on a fire. It was incredible. The Indian government had to bring in like 13,000 troops to put down the violence. This was really serious stuff. And here's just a couple seconds of it. Anyway, it's pretty gruesome. I'm not going to show you anymore. It really is gruesome. Now, it turns out that this is actually a video that shows two guys getting beaten to death by a mob. That part is true. The trick is that it wasn't those two guys. In fact, it turns out it wasn't even in India. This was an event that had happened in Pakistan 2 years earlier. It was two guys. There were no Hindus. They were all Muslims. It wasn't the issue. This was in a village where in a town where two guys were caught as thieves. And people went wild. They beat these guys to death. They dragged their bodies through the street. They strung them up. I mean, it was really, their dead bodies was really a horrific thing. But all somebody had to do was repurpose it. So they did what I would call a cognitive vulnerability analysis, which is just a fancy way of saying, what are people prepared to believe without too careful of an examination? So under the circumstances where there was already violence and things were looking dicey, when somebody put this up and said, yes, it's a Muslim mob beating to death these two Hindu guys, people were prepared to believe that. And so they did. And this was very effective. So it required no technical skill at all, just a little psychology. Now, here's another case. This one is really fun. It requires epsilon more skill. I mean, just a little tiny bit more skill. This was a tweet that was put up in 2017 by Chris Salissa, who is actually, I mean, he's a real editor at large at CNN. And he put this thing up. And what it's showing is Donald Trump and his wife visiting Poland. And he's on stage with the Polish prime minister and his wife. She's the lady in the pink there. And Salissa said, oh my God, oh my God, oh my God, the Polish prime minister snubbed, or prime minister's wife snubs Donald Trump. So here's what he showed on his tweet, his Twitter thing. You see, she walks right by him. So he said, oh my God, oh, this is horrible, right? So now let me show you what actually happened. So it turns out this is just a tiny clip of the real scene. The real scene was this. So what you saw here is with the rest of the story, right? So what the Polish prime minister's wife did was she followed Polish protocol. And what she was supposed to do was first shake our first lady's hand and then shake the president's hand. That was what she was supposed to do. That is what she did. And when you add in the soundtrack, what was actually going on, people chanting USA, USA, in obviously a very positive, enthusiastic way, you see that his tweet, what he put up, that this was totally bogus. I mean, this was just a lie. This was a total disinformation campaign, but he didn't alter the image at all, the video at all. He just cut it off on two sides, but he didn't alter it in any way, right? He just took a little piece out of context. So this required a little tiny bit more skill. This is a nice example. It shows some of the techniques that people are using.
Look at this video from Saturday Night Live that someone altered and posted on YouTube.
I'm sorry, Lester. It's This is going so well.
On the left, Kate McKinnon as Hillary Clinton. On the right, Clinton's face digitally inserted. They did the same trick with Vladimir Putin. People can now buy software and doctor video at home to create what's called deep fakes. At Carnegie Mellon University, Professor Alan Black specializes in speech synthesis. He shows us how it works with an audio clock. He has me read some times. The time is now almost 12. And then plugs my voice sample into a synthesizer. He's able to have me say whatever he types. The time is now exactly 3 in the morning.
Okay.
I didn't say that.
So?
Yeah, exactly. So just think how much fun you can have with that.
Look at this video from Saturday.
There's a slightly more modern version, which I think this is an interesting one because it shows that all you need with this technique is like 5 seconds of somebody's voice in order to clone it. 5 seconds. Think about it.
Dear fellow scholars, this is 2-Minute Papers with Károly Zsolnai Fehér. Today, we are going to listen to some amazing improvements in the area of AI-based voice cloning. For instance, if someone wanted to clone my voice, there are hours and hours of my recordings on YouTube and elsewhere. They could do it with previously existing techniques. But the question today is, if we had even more advanced methods to do this, how big of a sound sample would we really need for this? Do we need a few hours? A few minutes? The answer is no, not at all. Hold on to your papers because this new technique only requires 5 seconds. Let's listen to a couple examples.
The Norsemen considered the rainbow as a bridge over which the gods passed from Earth to their home in the sky.
Take a look at these pages for Crooked Creek Drive. There are several listings for gas station. Here's the forecast for the next 4 days.
These take the shape of a long round arch with its path high above and its two ends apparently beyond the horizon. Take a look at these pages for Crooked Creek Drive. There are several listings for gas station. Here's the forecast for the next 4 days.
Absolutely incredible. The timbre of the voice is very similar, and it is able to synthesize sounds and consonants that have to be inferred because they were not heard in the original voice sample. This requires a certain kind of intelligence and quite a bit of that. So, while we are at that, how does this new system work?
Well, I'll stop here because I can see that I've run out of time.
Dear fellow scholars,
You can look up the paper yourself. I have lots more fun examples. If anybody wants to see, we can show during the discussion.
Dear fellow,
I was going to just show you one more thing, though. Well, this is kind of fun. Just to see this. So I'm sure many of you have seen the Harry Potter movies, and they have the newspaper with the moving pictures in them. Well, here's the real thing. So here's a service called myheritage.com where you can upload a picture, a still photograph like this. And what it does is it animates it. It's just like a Harry Potter show, except this is real. Anyway, one last thing, and I'll stop there. I just want to show a little bit of this. This was somebody who made a video of Tom Cruise. Now, when I said before, you can have anybody being anywhere you want, saying anything you want, and here's a great example of how it looks.
That's why. It's it's a little embarrassing, you know. It reminds me, it was once in Russia, I ran into Gorbachev. He said, "You know, Mr. Movie Star, are you nervous?" I said, "No, Mr. Gorbachev, I'm not nervous." He goes, "Well, remember how much a polar bear weighs." I said, "Polar bear?" He said, "Enough to break the ice." It's the last time I've ever seen Mikhail Gorbachev. What's up, TikTok? You guys cool if I play some sports? I love it. More for the audio experience. As much as the momentum. Hey, listen up, sports and TikTok fans. If you like what you're seeing, just wait till what's coming next.
right, I'll stop there. So yeah, just wait till you see what's coming next. That's where I will leave it at the moment.
That's excellent. Thank you, Dr. Waltzman. So, I'm now here in real person. People probably don't realize that was actually not me in introducing Dr. Waltzman earlier. And we tried to make it realistic by me not starting the slides and having Dan interject, right?
Right.
All right, so let's have some Q&A. So the first one wasn't quite a specific question. Alexander here has mentioned that he really likes the hybrid format proposal we have. So I'm glad you are looking forward to that. We are as well. Kevin's posting a question for you, Rand. Is The Social Dilemma a good documentary to look into?
Yeah, it's okay. I mean, it's there's another one though I would recommend even more over it. If you're going to spend some time watching something, there's something actually much more interesting. Now it's historical. I mean, it tells you about how we got to where we are basically. And the name of the documentary is called The Century of the Self. So The Century of the Self, and you can find it on YouTube. But I'll warn you right now, it's 4 hours long. And I guarantee that it is worth every minute because it'll really tell you the history of exactly how we got to where we are today.
Wow. In
pretty interesting terms. I mean, it really starts out with a history of a guy by the name of Edward Bernays. And Edward Bernays, he is considered to be one of the founders of the entire field of public relations. And he was a very interesting guy, and he pulled off many spectacular influence operations. For example, he was the guy, and this was starting in World War I. So he was involved in something called the Committee on Public Information. So for those of you who are not familiar with that, the Committee on Public Information was a government committee for propaganda that tried to convince the American public that we needed to enter World War I. And Bernays was involved with that. So that was one of his early efforts. But he did many more things, and one of the most spectacular efforts, and they talk about it in this documentary a little bit, is he was the guy who introduced smoking to women. And the way he went about it was actually pretty fantastic. Because it was the president of American Tobacco, who makes Lucky Strike cigarettes, who went to him and said, half of the population doesn't buy my product. And he was talking about women. He says, so there's gold lying in my front yard and I am not picking it up. He said, how can I fix that? So Bernays thought about it, and he looked at the package of Lucky Strikes. He says, your first problem is that the package is green. He says, green isn't really a very popular color among women. So he said, you should change the color of the package. And the guy from the American Tobacco said, well, look, I just spent a fortune redesigning the package. I'm not going to change it now. So Bernays, not to be discouraged, said, okay, I can fix that too. And what he did is he decided he was going to make green a popular color among women. So what he did, for example, he went to Paris. And in Paris, he went to all the big fashion houses, and he told them, he says, look, next year in the US, green is going to be the color. So you need to start pushing green, make green clothes. And then he went back to the US, and he went to all the big department stores. He says, look, I just came back from Paris, and they told me that next year, green is going to be the big color. So you need to start featuring green in all your window displays and everything else, right? So that was part of his scheme. And then he had something like a green ball, a big charity ball. He invited all of these people to come, and all these big, society people, and everybody should be dressed in green. So that was another trick. And then, to make smoking look more interesting to women, in an Easter Day parade, he had a bunch of sort of young suffragette type women walking in the parade. And suddenly at one point, they all took out cigarettes and lit up the cigarettes, and which scandalized people, of course. And he called the cigarettes, he called them freedom torches, which I thought was good. Now, it turned out the word freedom, the expression, it wasn't his idea. He took it from somebody else, but he used it in a very effective way. And he had, at the end of the parade, a whole group of reporters standing around waiting to interview these women. And they did the story about these women with their freedom torches and, their right to smoke and to be equal to men. And the story went viral. So, this is a long time ago, but the similar kind of technique was used. He did other things. He was a spectacular character. In fact, he wrote a book, which I highly recommend to you all. It's called Propaganda. That's just the name, Propaganda by Edward Bernays, Bernays, Edward Bernays. And it was written in 1928, which is absolutely astonishing. And I mean, the advice in it and the whole ideas in it were just, I mean, spectacular. I mean, we really got it down. In fact, it's a really interesting story that Joseph Goebbels, another master of propaganda and disinformation, the story is that there was an American journalist who went to interview Goebbels. This is after he became propaganda minister, but before the war. So this guy went to interview him, and Goebbels took him into his library, and on a pedestal all by itself, in a place of honor, was a well-worn copy of this book, Propaganda by Edward Bernays. So, I mean, that's a very high recommendation for the quality of the book, I have to say. So,
yeah.
Anyway, watch that documentary. Much better, much more interesting than the thing seeing the thing about Facebook.
Right. Okay, thank you. Kostas is asking, are there countermeasures that can be employed to deceive the AI? Also, do you find the need for legislative or regulatory measures to restrict the use of these technologies?
Well, okay, I'll take the second question first. Legislation to restrict the use of technology is a loser to start with. I mean, that's, there's no way to control. I mean, how are you going to control that, really? I mean, that's up to me. But at this, it isn't like nuclear weapons. Nuclear weapons has a high cost of barrier to entry. It's really complicated. You really need to know what you're doing. I mean, it's a whole big complicated thing. It's really expensive. You're talking about technology which is cheap, which is pretty easy to use by anybody. Just about, as it's becoming increasingly commoditized and becoming more and more packaged up, more and more easy, So, I mean, trying to control the technology, I'm afraid that's just stupid. I mean, OpenAI, for example, when they came out with GPT, they said, well, this technology, is so dangerous that we're not going to tell anybody how it was done. Well, this idea was like so conceited and stupid. I can't even imagine, right? Because why did they believe for any minute that they came up with the idea, somebody else couldn't come up with the idea, something similar? I mean, it's just these ideas, they become in the air and they crystallize out in many multiple points simultaneously. I mean, that's, if you look at the history of invention, I mean, that's what happens. That's why you'll see historically multiple people coming up with the same invention at similar times, because it's already in the air, it's in the atmosphere, it's just ready to come. So controlling technology, that is a loser. I don't believe in that at all. So now, I'm sorry, what was the first part of the question?
The other question was really about, whether there are countermeasures that could be employed.
Yes. Yeah, well, sure, there are lots of countermeasures. So the problem is, are you willing to use them? It's less that there are countermeasures, that there are possibilities. It's more about, are people willing to use them? For example, adversarial attacks. One of the things that especially statistical-based machine learning technology, it expands the attack surface of a computer system tremendously, right? Because in normal hacking of classical, traditional programming systems, you actually have to break into the system. Well, guess what? With statistical machine learning systems, you don't have to break into the system. They can be deceived from the outside by exposing them to the right kind of data. You can, there's famous examples, right, with vision systems. You have a stop sign and you put a little tiny sticker on one corner and all of a sudden it perceives it as a speed limit or something like that, right? So there are ways, so it expands the whole concept of deception. I mean, after all, I can deceive you as a human being without drilling a hole in your head, right? I don't have to administer drugs. I can fool you in all kinds of ways. And these systems introduce the possibility to do exactly that. Okay, of course, then there are things like data poisoning attacks where you actually have to break into a system, but there's lots you can do, to counteract the systems like that. Mm-hmm. And then there are, when it comes to really disinformation, then you really get into the concept of, well, how do you actually counter disinformation? And for my money, it isn't really countering so much as it is displacing it. So that means that you have to be basically bigger, better, and faster than the other guy. You have to come up with a more compelling story, faster than him, and get it out faster. And then people buy your story and sort of forget about the other guys. So, and there are ways to help people to, sort of instinctively detect, realize that somebody's trying to put the wool over their eyes. So, I mean, so there's sort of the whole concept of information inoculation, which I think has a lot of interesting possibilities to it, or I call it cognitive inoculation, which means that you become sensitive somebody trying to put something over on you in the information space. And, there are a wide variety of techniques to actually do offensive operations in the space. I mean, a wide variety. And you can actually learn to start to recognize when somebody is using them. And, in a physical attack, in a kinetic attack, when you're being attacked. I mean, if somebody comes up with you a knife or a gun or throwing bombs at you, I mean, you're being attacked. There's no doubt about it, right? But in cognitive attacks, in manipulation attacks, the attacks are most effective when the target has no idea that they're being attacked. Okay, that's really a key. And in fact, it turns out that simply by recognizing that an attack is underway, the attack loses a lot of its force. I mean, not completely, of course, but, it's like vaccines. It's not 100%, but pretty good. So just by learning to recognize when you are being attacked in this way, that actually does a lot. And so in that case, it doesn't matter whether it's being done manually or automatically, or there are lots of ways to learn to recognize that.
Right.
So that's really the best, to me at the moment, that's one of the best things certainly that you could do. Then we can get into much more complicated things like, for example, there's a whole concept, I have something I call, say, computational plausibility. How can I calculate whether a given story to a given audience will be plausible to them? Okay, so how would I calculate that? So if I have a way to actually calculate plausibility, one thing I could do is if somebody's coming at me with a story and it's automated, I can have my own automation that says, okay, by the way, this thing is just not plausible. And it just automatically tell me that. It doesn't even have to tell me whether it's true or false. At least it can tell me, well, just on the face of it, doesn't really make any sense, according to my current view of the world.
Right.
So there's a whole host of things like that you can do. I mean,
yeah.
By the way, I just wanted to just say one quick thing about what Mr. Morris has, his question here. They're being used, are we developing countermeasures? The answer is no. No, the government is doing nothing. The government is absolutely worth it. The US government has decided to leave you, the population, completely defenseless. That's been the decision, whether it's been explicit or implicit or however you want to describe it, but that's where it is. I'm sorry to report.
Right. Okay, and that covers the anonymous question after Windsor's as well. Ryan quickly asks, do you think there will ever be a parameter limit to the NLP models being created for the future, like GPT-4, et cetera? So I mean, there's some really interesting work, about, the structure of neurons in the brain, right? And they showed that, the types of artificial neurons we use in neural networks, they would never be able to implement the capability of neurons as they exist in the brain, for example. I mean, there's, all kinds of things having to do with dendrites and dendritic processing. And, like in one paper I was reading, it said, well, it would take 1,000 artificial neurons to implement one brain neuron, something like that. So, where the limits are exactly, it's hard to say, but I mean, we've already reached kind of limits in the sense that if you look at a system with, 1.75 trillion parameters in it, like Wu DAO 2.0, right? I mean, think about how much power a thing like that takes and the footprint that it has. I mean, these are enormous systems. At some point, it's not practical anymore. So, and since the human brain seems to function and doesn't require nearly that much power, I mean, something is wrong the way we're approaching it. I mean, it's just not, right? It isn't sustainable. But it also doesn't mean it's not useful, right? I mean, because there's plenty of applications which that's all you really need. That the techniques that we have will work fine and build really useful systems. It's a little bit like expert systems in the 80s. Well, it wasn't the general technology, but there were plenty of systems that using that technology, you could build really useful working systems that really helped you out. So it's really a question of what you're trying to accomplish, right? So with that, Rand, I guess we'll see you on the Zoom meeting.
All right, I'll be there.
Awesome.